Hey everybody, so the purpose of this video is to remind you how to simplify square roots of numbers and to add a little twist onto the end that'll take us into our next section. So the first thing I have here are two square roots, square root of 108 and the square root of 128, neither of which come out as a nice pretty integer. And I want to remind you how you go about simplifying square roots of numbers. So the first thing I'm going to do is factor the radicand. Now the radicand is the number underneath the radical. So this 108 in the first problem is the radicand, and the 128 in the second problem is the radicand. So I'm going to factor 108, and the way I'm going to do that is with a factor tree. So I need a number that goes into 108, and I can think of anything from like 2 because it's even, or 9 because the digits add up to 9, that's divisible by 9. I'm going to choose 9. 9 goes into 108 12 times. Neither of those is prime, so I'm going to keep factoring. 9 is 3 times 3, 12 is 3 times 4, 3 is prime, so is that one, so is that one, 4 is not, so I need to factor that fully. So I've fully factored my radicand. So that's going to be 3 times 3 times 3, 2 times 2. I'm going to do the same thing with my 128. So my 128, I know that, let's see, how about 8 goes into that? And it goes into that, let's see, 16 times. 8 is 2 times 4, 2 is prime. 16 is 4 times 4, none of those 4s are prime. So we need to break them up. And now we have all these 2's are prime, so that's broken down as much as it can be. So I have 1, 2, 3, 4, 5, 6, 7 2's in there. Now, once you've got your radicand factored, what you're going to do is you're going to pair up factors. And the reason we're going to pair up factors is because square roots look for things that have the same factor twice. So I'm going to look at this top thing, and I see I got a pair of 3's. So I'm going to put those under their own little house. I got a pair of 2's, so I'm going to put those on their own little house. And then anything that doesn't have a pair is going to go in its house together. Now in this case, it's only a 3. Now, this would be the square root of 9, right? And the square root of 9 is 3, not 9. I just wrote that number 9. That's why you want to look to pair up the factors, because you'll get something nice and pretty out of it. The square root of 2 times 2 is the square root of 4, that is 2. And then the square root of 3, I can't simplify that. I'm going to leave that as the square root of 3. So when I have 3 times 2 times the square root of 3, that's 6 times the square root of 3. I'm going to do the same thing on this bottom one, just without all talking. Pair of 2's, pair of 2's, pair of 2's, and the single 2. So this would give me 2, 2, 2, and this would give me the square root of 2. So this is 8 times the square root of 2. Now I will say, when I do this, normally I jump straight from writing this step with all the factors and circling to this step. I don't go through the breaking up into individual square roots. Whichever way works for you is the best. Now, that's something we're going to need, because what we're really going to talk about in this section is something that seems a little weird, and that is this. We were breaking things up into individual radicals and then taking square roots of negative numbers. So first of all, you should know from Algebra 1, if I take the square root of 4, for instance, square root of 4 is 2, but why is that? Well, it's because when you take 2 and you square it, that gives you 4. Now, technically, another square root of 4 would be negative 2, because when you square it, it also gives you 4. But typically, we know we want the negative root when it tells us in the problem that we want the negative root. So like negative square root of 4 will be negative 2. Square root of 4 will be 2. Now, if I talk about doing a square root of negative 9, there's a problem with that. Because if I think about numbers that you square it gives you a negative number, if I pick 3, 3 times 3 is positive 9, not negative 9. If I pick negative 3 times negative 3 is positive 9, not negative 9. So really there's no real numbers that equal this. that doesn't mean that we can't figure out a value for it. And this was a problem that arose, I think, back in like the 1400s. They were kind of dealing with this idea. Remember, math has sort of developed over the course of centuries, and when numbers were first developed, people used them to count. There were no such things as negative numbers. There was no such thing as even zero in a lot of cultures. There were no such thing as fractions or decimals. And all of those things, negative numbers, zero, fractions, and decimals, have been things that have been invented by people to explain phenomena that they needed to explain. So when you get into the 14 and 1500s, they're dealing with these square roots of negative numbers and saying, we should be able to do something more with these than just say they're not real. So there's this man named Rene Descartes. You may have heard of him, you may not have. But he's looking at the problem saying, we have a square root of -9. So it's not the fact that it's -9 that's really the problem, it's the fact that it's negative. So I'm going to take this -9 and rewrite it as -1 times 9. Now, just like we did on the last screen, where we're applying them, we're going to do the same thing here. So I can rewrite the square root of -9 as square root of -1 times the square root of 9. Well, square root of 9 is super easy. That's just 3. So this would be 3 times the square root of -1. Now, when Descartes was working with this, he came down that every single square root came down to a number times the square root of -1. So it's the square root of -1 that's really the problem with taking the square roots of negative numbers. So what he did was something fairly clever. He basically said, hey, this square root of -1, this is the issue with all of these square roots of negative numbers. So I'm going to give it a name. I'm going to call it the imaginary unit. And that's too long for me to write every time, so I'm going to write that imaginary unit, which is the square root of -1, is equal to the letter I for imaginary. Now, when he first called them imaginary numbers, he was actually being insulting, but we'll talk more about that at a later time. So he would write the square root of -9 is 3 times the square root of -1, which is 3 times I. So anytime you have a square root of a negative number, it will involve this imaginary unit. That will take care of the negative, and then the rest of the number you can take the square root of normally. So let me show you an example of how that works really quickly. So if I wanted to find the square root of -27, the first thing I would do is think, okay, this is a negative number. I need to break off the -1 so I can deal with the 27 normally. The square root of -1 we're going to define as I. So I would replace that square root of -1 with an I. And then 27 we're going to deal with the way we did on the last screen. Factoring, writing out the factors, looking at the pairs, and then if I wanted to show all the work, writing it in separate square roots, and then writing this like that. And again, I often skip directly from this step to this step. So anytime you're taking the square root of a negative number, you can deal with a negative by putting an I out in front, basically sort of popping off the square root of -1, and then dealing with the rest of the square root on